This part is clear. Mustafa, clear this part.
Yes, sir.
Okay. Next is mean square velocity. If you understand this mean velocity, you can easily understand mean square velocity. Now, mean square velocity is represented by c bar square. Now, how to write? Same. Take mean velocity formula and put a square in left and right hand side. So this type of formula is called mean square velocity. Now we are making root mean square velocity. How to make root mean square velocity formula? Very simple. Mean square velocity, you have to put square root in both the sides. This is called root mean square velocity. I will understand how we are making different formula. Understood? We will do this small derivation. First, we will complete the big derivation, and the derivation name is pressure exerted by the gas. We will study here the pressure of the gas. This assumption part is removed by this board exam. This is the reducing part. Now, here, this is the derivation. In this derivation, we are making one formula. With the help of that formula, we can easily calculate any gas pressure. Okay, we are determining the pressure of the gas formula. So suppose we have a container. In this container, the gas is filled with this container. Now we know that gas is made up of tiny particles. Each tiny particle having speed. So suppose this tiny gas particle speed is C1. This tiny gas particle speed is C2. And we know that in each gas molecule having infinite number of particles. So we cannot give like this number C1, C2. So can we represent each gas's particle? Suppose it contains number of gas particles, their speed is C. Okay, so we can represent by Cn. Now we know that the gases particle motion, how they moving, they are moving in random motion. So in math, we know about random motion. How many type of motion is there? There are three types of motion. X-axis, either particle move in x-axis, either particle move in y-axis, or either particle direction or motion in z-axis. So we know about there are only three directions each gaseous particle having. So either they are moving in x-axis. So x-axis we are represented by, in this concept, we are represented by u. So I am representing by u1. Why I am representing by u1? Because the gaseous particle speed c1. So their x-axis speed also I am represented by 1 symbol. Now y direction is represented by v symbol, and the z direction I am representing by w symbol. So you represent the x-axis direction speed, and v1 is represent the y-axis direction speed, and w is represent the z direction speed of this gaseous particle. Okay, understood this part, students? This is a cylindrical cube. Okay. Anyone having any doubt here?
एक बार वापस समझाइए ना सर, एक बार ये
What
एंडिंग का
part?
पार्ट सर.
What
सर
I'm saying,
एंडिंग का सर.
ending part. How what we are supposing here? See, each gaseous particle moving in random motion in everywhere. Correct ना? So in math we have the motion. हम लोग मैथ में मोशन पढ़ा है कि कोई पार्टिकल कितने मोशन कर सकता है. करेक्ट? मैथ ने बता दिया है हम लोग को वेक्टर कॉन्सेप्ट में. बट वेक्टर से एनी पार्टिकल मूव इन ओनली 3 डायरेक्शन. 3D पढ़ा है ना, 3D ज्योमेट्री. बट 3D से के डायरेक्शन से 3 ही हो सकते हैं. अगर कोई पार्टिकल की वेलोसिटी वो मोशन कर रहा है तो आइदर एक्स एक्सिस. तो एक्स एक्सिस वी आर रिप्रेजेंटिंग हियर बाय यू, y axis we are represented by v, and z axis direction we are represented by w. So what I'm saying here is this speed of gas particle, either they are moving in u direction, either they are moving in v direction, or either they are moving in w direction. उसके पास सिर्फ 3 ही डायरेक्शन है मोशन करने के. करेक्ट? दिस पार्ट इज क्लियर नाउ? उससे ज्यादा कोई मोशन कर सकता है क्या? बिकॉज मैथ्स में तो मोशन के लिए 3 डायरेक्शन ही दिए हैं. इससे ज्यादा कोई डायरेक्शन नहीं जा सकता कोई भी गैस पार्टिकल. So we are supposing each gaseous particle speed by u1, v1, w1, and similarly second gas particle we are represented by u2, v2, and w2. Here negative sign. See, one particle having negative sign. This negative sign represent the opposing direction. Suppose अगर कोई पार्टिकल है गैस वो अपने फॉरवर्ड डायरेक्शन में जा रहा है, जब वो एक्चुअल अपनी स्पीड यूज कर रहा है, तो दे आर यूजिंग देयर ओन स्पीड, so their speed we are represented by positive symbol. When they are falling to or striking to the wall, now because of wall they change their direction as well as their speed, so now the speed is come from this wall, so that is why we are represented by negative sign. Negative sign represent they are going to opposite direction, correct? In physics, opposite direction we are represented by negative sign. Clear is this part? We will see detail about this negative sign. Okay, in this gas container, now n is represent the total number of gas molecules. This gas container contain infinite number of gas particles. The total number of gas particles we are represented by gas molecule. Small m is represent each gas particle mass. Okay, so what about capital M? Capital M represents total mass of the gas. That means capital N multiplied by small n represent the total mass of the gas. So how to calculate their area? We know the area formula. This look like a square. So we know about square, side ka square. So here we are representing side by length square. Okay. Second, we know the formula of volume of cube. What is the formula of volume cube? You already studied this part in chemistry solid state chapter. Volume of the cube. Remember BCC, SPC, and HCC, solid simple cube. So volume of the cube formula is side cube, that is length cube. This part is clear, students? Anyone having any doubt here?
Oh, sir.
Now for fluid, in fluid chapter we study. When we study fluid, we also study density, because how much that thing is occupied in that area. So density, what density is represented by rho. Now here we represent density by gas. It's nothing but mass upon volume. We know the formula of volume. What is the formula of volume? Side cube. So we replace V by L cube. Remember this part. We will use this part later on. Now we consider here. Consider we have a gas molecule which is enclosed in a gas container, and their speed of each gaseous particle we are represented by C1, C2, and Cn. Now here C is represent the speed of gas particle. The number is represent the each gaseous particle. I am putting the number of each gaseous particle, but we can't put each gaseous particle number, so we are represented by dotted Cn. Cn why I am taking? Because each gaseous particle contains infinite number of gas particles, correct? Okay. Now we know the vector concept. What is the formula of vector? Distance r square is equal to x square plus y square plus z square. This is the distance formula of vector, correct? So this formula we are applying here, this equation for this concept, because see, each gaseous speed of particle is represented by three directions, correct? Y direction, x direction, and z direction. That is why we are representing this distance formula. Suppose this r is my c, and this each direction is my x-axis, y-axis, and z-axis, correct? Now we know that x-axis we are represented by symbol u, y-axis we are represented by v, and z-axis we are represented by w. So can we write like this? C1 square is equal to u1 square plus v1 square plus w1 square. I hope you understand this part, how we are getting this part. Anyone having any doubt? Because this derivation is very big. Clear this part? Okay. Similarly, can we write C2 equation? Gas of particle of C2, u2 square plus v2 square plus w2 square. I hope you understand. Now we know that in each enclosed cylinder contain infinite number of gas particles, so we can't give each number C3, C4. So we directly represent by Cn square is equal to Un square, Vn square plus Wn square. So these are the value of C1, C2, and Cn. Clear this part? Anyone having any doubt here? Now coming to again that closed tube cylinder which contain a gas. So we assume one gas. Suppose this is C1 gas. Now we know that the gas particles travel in three directions: x-axis, y-axis, and z-axis. So we are supposing one direction, that is nothing but x-axis. Now in x-axis direction we are represented by which symbol? U1 symbol. Now coming to the momentum concept. What do you mean by momentum? Momentum is nothing but the product of mass into velocity. When we study mass and velocity both together, that concept is called momentum. In here we will study momentum. See, the gaseous particle having mass as well as this gaseous particle is moving in particular direction. So can we say that the gaseous particle performing momentum? We name this enclosed cube by PQRS and backside is P dash Q dash and R and S dash. Okay. Now suppose this C1 particle is moving in x-axis direction. At starting position, they start from this PS side, correct? And this lower line is represent the length. From left to right, they cover length distance. When they strike this wall, right hand side wall, they are going to opposite direction. In that case, when they are bouncing this wall, their momentum is change, correct now? So can we say that the final momentum is change? And that condition, when initial momentum is positive, so initial momentum we are represented by mu1. When they fall to this wall, their momentum is opposing because their direction is right hand direction. Because of wall, their direction is changed. Now they are moving in opposite direction. So opposite direction momentum we are represented by minus mu. So initial momentum is plus mu1 and final momentum is minus mu. Final momentum represents the striking momentum when they strike to the wall and bounce back to in the opposite direction. I hope this part is clear. Anyone having any doubt? Now we know about change in momentum. What is change in momentum? Now change in momentum we represent by delta P. Now how we are getting this symbol? So we are getting this symbol in chemistry, right? Remember, change we are represented by this delta symbol. Now change in momentum is nothing but final momentum minus initial momentum. What is final momentum? Final momentum value is minus mu1. Initial momentum value is plus mu1. Minus is already there. So minus minus become plus, correct? So mu1 minus mu1, we are getting minus 2 mu1. What about this momentum? This momentum is based on the gaseous particle, correct? But we need momentum based on wall. If gas particle based momentum is negative, what about the wall based momentum? Of course, the wall based momentum is positive. So just replace the sign and write the same thing. So based on wall momentum, there is plus 2 mu. This part is clear. Anyone having any doubt? Pakka? Shall we go further? Okay.
Yes, sir.
Yes.
So remember this momentum, we need wall momentum. We know about the speed formula. What is the speed formula? Distance upon time. Take this time here and take this speed right hand direction. What we are getting? Time is equal to distance upon speed. Correct? Now in this case, see, the first gaseous particle is traveling from left to right direction. So they cover one particular distance which is represented by L. Now after striking this wall, they are going to opposite direction. Again they are going to opposite direction. Again they are cover one more distance. So L plus L is how much? 2L. So each gaseous particle covered two distance. That is mean by 2L. I hope you understand how we are getting 2L. Now here we are taking example of x direction. So x we are represented by u. That is why I am taking here u1. If we understand one axis direction speed, we can easily calculate different direction speed, because in each different direction the speed is always constant. Okay. We know that force Newton, according to Newton's second law. What is the formula of Newton's second law? Force is equal to mass into acceleration. Correct? What is the formula of acceleration? Change in velocity upon time. This is the formula. Correct? What about this? Mass into velocity. Mass into velocity is nothing but momentum upon time. Change in momentum upon time. Have you understood how we are getting force ka second formula? What is the force different formula here? Change in momentum of the wall upon time. So can we write Newton formula by like this? Force is equal to change in momentum of the wall upon time. Now suppose this is first particle force formula. So can we write like F1? So F1, change in momentum. What do you mean by change in momentum? What is change in momentum here? So change in momentum is nothing but the wall momentum. How much we are getting? Wall momentum 2 mu1. Remember? So we are here, we are putting what we are putting here 2 mu1. Now time. What is the value of time? See here. What we are getting time value? 2L upon 2L upon u1. Now 2 and 2 is cancelled. Now this L is goes to, now 2 and 2 is cancelled. Here we are writing here, and they take this L downward and take this U1 is upward. How we are getting this? I hope you understand. This part is multiplied by this part, correct? And this part is divided by this part. Basic mathematics सभी को पता ही होगा. So how we are getting this? I hope you understand. 2mu1 square upon 2l. Now 2 and 2 is cancelled. What we are getting? F1 is equal to mu1 square upon L. This is the first gaseous particle x direction force. What about the second F2 direction force? Same. अगर इसका mu1 आ रहा है तो second force क्या होगा x direction का? mu2 square upon L. Understood, student? So we have number of gas particles. So their force is Fn is equal to mu square upon L. I hope you understand this part. Anyone having any doubt? This part? Yes, student. Tabassum.
Yes.
Clear this part?
Yes, sir.
Now, what we have to calculate? We are not calculating each direction particle. We are calculating the axis direction. If we want f of x, that means force of x direction. How we are calculate force of x direction? We are adding all these force. When we are adding all these force, what we are getting? F1 plus F2 plus F3 dotted Fn. What is the value of F1? mu1 square upon L. Correct? What is the value of F2? mu2 square upon L. What is the value of F3? mu3 square upon L. Similarly, what is the value of Fn? mun square upon L. So what is the common of all these parts? M upon L is the common part, right, students? So take M upon L common. What is the uncommon part? Take in this bracket. What we are getting? u1 square plus u2 square plus dotted un square. Similarly, can we find out force of y direction? Same method we are using. Just change the symbol. Here what we are writing here, x direction we are represented by u. For y direction, what we are represented by v, and z direction, what we are represented by symbol w. Correct now? So change the symbol. U we replace by v symbol. So v1 square plus v2 square plus dotted vn square. Similarly, in z direction, force we are taking same formula. Just replace this symbol w1 square, w2 square, and dot plus wn square. This part is clear, students. We are getting each direction force.
Yes.
What about remaining?
Yes.
Now we know that the formula of pressure. What is the formula of pressure? Force upon area. So first we are calculating each direction pressure. So each direction pressure, Px is equal to f of x upon area. We know the formula of area. What is area? Length square. Correct now? And we have f of x. What is f of x? See here. What we are getting f of x value? M upon L, u1 square plus u. So we are putting here. So we already have L square. Correct? And एक L यहाँ पर भी है. This both L is multiplied. What we are getting? M upon L cube. And the remaining part same पूरा के पूरा यहाँ पे we are doing copy and paste this part. Similarly, can we find pressure of y-axis? How we are getting pressure of y-axis? We know the formula, force of f of y upon L square. So what is f of y? M upon L, v1 square plus v2 square plus dotted vn. So we are just copy and paste here. But we are getting m upon L cube, v1 square, v2 square, and vn square. Correct? Similarly, we are getting pz formula. Only what is the difference? U, V, and W. Now we know that जो pressure होता है वो each direction में क्या होता है? Constant होता है. Always they are same in each place. But we are study this part. Pressure is always constant. Where we study this part? In thermodynamics. I hope your teachers tell you about this in chemistry. The pressure is always constant. I hope you remember chapter number 2, thermodynamics. Remember? So can we say that the each direction pressure is equal? So can we write that sum of pressure Px, Py, Pz is equal to 3P. How we are getting 3P? Because each pressure is same. So can we replace Py by Px? Can we replace Pz by Px? Yes, of course. We are replacing each same symbol. So that is why I am writing here 3P. Now take this 3 on left hand side. So what we are getting? P is equal to Px plus Py plus Pz upon 3. Clear this part? Now we are very near to the derivation formula part. Now we have Px Py value. Put here Px Py value. What is the value of Px? M upon L cube. This is the value M upon L cube. U1 square, U2 square, dotted U1 square. What is the value of Py? So how I am writing here 6. अपॉन को मैंने कहाँ पे लिखा है, नीचे लिखा हुआ, और मैंने purposely I am writing like this, okay. Now plus, so plus part I am writing down M upon L cube for Py, M upon L cube V1 square plus V2 square plus dot Vn. Similarly, again I am putting plus, see I am putting here plus M upon L cube W1 square plus W2 square plus dot Wn square upon 3. What is, now add this whole M upon L cube. If we are adding this whole part, what we are getting here? If we are adding this whole part, we are getting M upon 3 L cube. Total 3 M upon L, hai na? So can we write like this, M upon 3 L cube? Now say, second thing. Remember the starting formula. What is the value of C1? U1 square plus V1 square plus W1 square. कुछ याद है? मैंने बोला ना starting में, याद रखो इसको. We are using this.
Yes, sir.
C2 का formula क्या था? Can see here? U1 square plus V1 square plus W1 की जगह मैं क्या रिप्लेस करूंगा? C1 को. U2 square plus V2 square plus W2 square. What I am replacing here? C2 square. Similarly, for n, we are replacing by Cn square. Have you understand how we are getting this? Now we know the formula. L cube मैंने किसके लिए यूज किया था? Volume of the cube का formula क्या था? L cube. So replace this L cube by V. Now, just we are throw root mean square velocity formula. What is the root mean square velocity? Crm is equal to square root of C1 square plus C2 square plus dot Cn square upon n. ये formula किया था. Now I'm stopping here derivation थोड़ी देर के लिए. Now take this square root left hand side. So what we are getting? Square RMS is equal to C1 square plus C2 square and so on. Take this n left hand side. So what we are getting? C1 square plus C2 square plus dot Cn square is nothing but C square RMS. Now see here, यहाँ और ये वैल्यू सेम ही है. So can we replace this by this value? तो हम लोग क्या करेंगे? C1 C square, C2 square plus dot Cn square की जगह पे we are replacing by this value, C square RMS by n. So I'm putting this here. So what I'm getting here, P is equal to 1 upon 3 M upon V, C square RMS n. Now take this n out. So what we are getting? 1 upon 3 M capital N upon V, C square RMS. Now remember, the mass of the gas molecule is nothing but number of gas into mass of each gas. ये मैंने बताया था starting में. Correct? So can we replace M
Yes, sir.
dot capital N by capital N? Now we know that mass upon volume is nothing but density. We know the formula of density. Remember? So remember this formula. We are using this formula. Now we are replacing this mass upon volume by rho. So what we are getting? Pressure is equal to 1 upon 3 rho C square Rm. Anyone having any doubt here? This derivation. This derivation is very big, and this derivation is very, very, very important for the board exam. Okay? And derivation is very simple. So we cover this formula. Now remember this formula. With the help of this formula, we can easily calculate gas pressure. Okay. Now, if we done this formula, now we are coming to previous part. That small derivation is there. I will tell you later. So that part we start now. Okay. So this part is not there. Where is, and we are going fast. So मैं दो derivation.
Sir.
Yes, student. हाँ तब
सर आपकी आवाज नहीं आ रही, जोर से बोलो ना.
मेरी आवाज नहीं आ रही है. What about others?
Yes sir.
Musab, Tabassum, can you? Voice is coming.
No sir. Clear नहीं है.
Voice is coming. अगर slow आ रहा है
सर
तो
हल्की आ रही है
it's okay ना. Now my voice is clear. Hello. Because this is internet
अरे
connectivity
जोया का
problem.
फोन ज्यादा अच्छा है ना सर, तो उसमें अच्छी आवाज आती है.
No, this is not a based on mobile. This is based on internet.
ऐसा क्या?
Yes. The problem is internet. My place is internet is very good. Might be the problem of the internet. That is why I'm asking each student. What about Kaif? You can hear me, my voice clearly? Saif, Musab, Abasum,
Yes, sir. Yes,
Aglut students. Okay. Now we start this small derivation. In this derivation, what we have to show that C RMS is directly proportional to square root of T. Correct? We know about C. C is nothing but speed. So how to calculate this derivation? Similarly, same we are taking pressure formula. Just we are calculating this formula. What is the pressure formula? P is equal to 1/3 rho C square RMS. We know that what is rho? Rho is something mass upon volume. So I am taking rho को replace किया I am mass upon volume से. Second, take this V left hand side. So what happened? We are getting PV is equal to 1/3 mc square RMS. Now, according to ideal gas equation, what is PV? PV is equal to RT. So replace this PV by RT. Clear this part, students? Arfa?
Yes, sir.
Okay. Now, accept this C square RMS. Take this 1/3 and m left hand side. So 3 goes up and this m goes down. So C square RMS is equal to 3 RT upon m. Now take this square right hand direction. So it creates square root. So C RMS is equal to square root of 3 RT upon m. Now we know that the mass of each gas is always constant, and R is, we already know, R is represent the gas constant. Correct? Now 3 is always constant number. जब भी रहेगा derivation में वो always क्या रहता है? Constant होता है. Correct? If we are taking 3, R and M constant, what is the left part? Only T. So we derive this equation. C RMS is directly proportional to square root of T. I hope you understand how we are calculating this derivation. Anyone having any doubt, students?
No.
If you
No, sir.
have internet connectivity problem, we have YouTube channels. Remember, students. So you can revise this derivation. Okay.
Yes,
Next
sir.
derivation.
मैं तो daily
Kinetic energy of gas molecule. In this derivation, what we have to calculate? Kinetic energy is equal to 3/2 PV. हम लोग को ये show करना है. So again, we are taking same formula. Pressure of the gas formula. What is the pressure of the gas formula? 1/3 rho C square RMS. Now we know about density formula, mass upon volume. So we take here mass upon volume, C square RMS. Now again take this V left hand side. So what we are getting, PV is equal to 1/3 m C square RMS. Next क्या करना है? Multiply by 2 करना. What we are doing? Multiply and divide by 2. If we multiply and divide by 2, what we are getting? I am writing here. See, 2 into 3/2. Correct na? Because I am multiplying, dividing. So multiply and divide by 2. What is the right side? Right part? MC square RMS. Clear this part? So this 2 and this 2 cancel. And this 2, इसको भी हम लोग cancel कर सकते हैं. Don't cancel it. Take this 2 right hand direction. What we are getting? 3/2 PV is equal to 1/2 MC square RMS. How we are getting this? I hope you understand. Anyone having any doubt here? देखो 2 derivation मैं करूँगा, 2 derivation तुम लोग को करना है. That is your assignment. So if you have any doubt, ask me. Correct? I hope you understand this part, students.
सर क्या करने का है सर? क्या assignment है?
The remaining 2 derivation.
Okay,
Now
sir.
first clear this derivation. You understand this derivation? How we are getting 3/2 PV is equal to 1/2 MC square RMS. Clear this part? We are multiply and divide by 2. Now next. Half MC. Now मैंने already बोला था, यहाँ पर जो C है वो किसको represent कर रहा है? Velocity को. M represent कर रहा है mass को. And we already know about the half mv square formula is nothing but kinetic energy formula. But this C represents the gas speed. So that is why can we write like this? Kinetic energy of gas is nothing but. So can we replace this half mc square RMS by kinetic energy of gas? Of course, because ये value किसकी है? Kinetic energy of gas का है ना? So if we replace by this symbol, what we are getting? 3/2 PV. So we derive this part. Understood, students? बहुत ही easy है. Simple type just given and putting value और कुछ नहीं. So we done 2 derivation. Now what about this next derivation? What we are calculating here? Kinetic energy per unit volume.